Welcome viewers, in this video we will see the solved problem based on the Tellegen's theorem. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. Verify the Tellegen's theorem for the circuit shown below. We need to verify the Tellegen's theorem for this circuit. The Tellegen's theorem is nothing but for any circuit the instantaneous power, the sum of instantaneous power is equal to 0. That is the statement of the Tellegen's theorem, and also the circuit should satisfy the KVL and KCL, Kirchhoff's voltage law and Kirchhoff's current law. So in this circuit we need to verify this power delivered by this source is equal to power absorbed by these elements, resistive elements. We need to verify, right? We have to identify what is the total power delivered by this source. What is the total power absorbed by this resistor? Well, both are equal. That is power delivered equal to power absorbed. So in order to find the power, we need to identify what is the voltage across each and every resistor. There are 4 resistors available: R1, R2, R3, R4. The voltage across R1 is V1, R2 is V2, R3 is V3, R4 is V4. And the current is the total current. First current is I1. Then it is split into I2, I3, I4 with the resistor R2, R3 and R4. So we need to identify, we need to find the value of V1, V2, V3, V4. Similarly I1, I2, I3, I4. From that we need to find what is the voltage drop, power across the resistor, and what is the power delivered by the source. Right. So in this circuit, by analyzing, it is clear that these 3 resistors are connected in parallel. R2, R3, R4 are connected in parallel. And also it is given R1 value is 1 ohm. This R1 is 1 ohm. R2, R3, R4 is 2 ohm. All the resistors having same value. 2 ohm and this also 2 ohm. Then what is that? The voltage drop across R2, R3, R4 are equal because it is connected in parallel and also values are equal. Similarly, the current flowing through the resistor R2, R3, R4 also equal because of same value of resistor. That is I2, I3, I4 also equal. I2 equal to I3, that is equal to I4. V2 equal to V3, that is equal to V4. Right? Now we'll find the values. Now first we'll find the total resistance of this circuit. What is the total resistance of this circuit? These 3 are connected in parallel, that is in series with the R1. Right? So first we'll find the total resistance. Then we'll find the total current. From that we can find the voltage V1, V2, V3. Then we'll find the I1, I2, I3. From that we can find total power. Right? Now we'll go to find the total resistance of this circuit. Let the first calculate the various currents and voltage drop. For that, first what we need? Total resistance or parallel. That is, these 3 resistors are connected in parallel. 1 divided by 1 by 2 plus 1 by 2 plus 1 by 2. That is 1 divided by 3 by 2, that is 2 by 3, because all the values are equal. If it is all the values are equal, we can use this formula. 1 divided by the resistor value, 1 divided by 1 by R value, right? So that it is 2 by 3 ohm, right? So and what is the total resistance R total? R total is nothing but 1 plus RP, right? The resistor R1 equal to 1 ohm, then the parallel resistor. So 1 plus 2 by 3, that is 5 by 3. The total resistance of the circuit is 5 by 3, right? So the first resistor R1 is 1 ohm, that is parallel with this, series with this parallel resistor. So that it is 5 by 3 ohm. This one is nothing but the resistor R1. This is R2, R3, R4. All values are equal. So from that we can find the source current, that is equal to I1. Both are equal. Now we'll refer the diagram again. This is R1. R1 value, that is value is 1 ohm. This R1 is series with this parallel combination. So that 1 plus 2 by 3. Similarly, the source current is equal to current I1. Both are same. The source current equal to IS equal to I1, because R1 is connected in series with the source. So that is Vs by RT. Vs is 100 ohm, 100 voltage. The total resistor is 5 by 3. So it is 100 into 3 by 5, that is equal to 60 amperes. So the voltage, the source current as well as the current I1 is 60 amperes. From that we can find V1. V1 equal to I1 R1. I1 is 60 amperes, R1 is 1 ohm, 60 voltage, right? So the I1 is equal to 60 amperes, V1 equal to 60 voltage, and also source current also 60 amperes. Now we will find the voltage drop across each and every element. Vs equal to V1 plus V2. In a closed loop, Vs equal to V1 plus V2. We will refer the diagram. So this is the closed loop. The voltage 100 what delivered is equal to voltage drop across R1 and R2. So 100 equal to V1 plus V2. Vs equal to V1 plus V2. The voltage what we applied is equal to voltage drop across R1 and R2. Based on that, Vs equal to V1 plus V2. From that, V2 equal to Vs minus V1. Right? Vs is 100 voltage. V1 what we calculated is 60 voltage. So 100 minus 60, 40 voltage. So V2 equal to 40 voltage. We know that this V3, V4, V2 all are equal. We already discussed all the resistors are connected in parallel and also the resistor values are equal. So the voltage drop across R2 is V2, that is equal to V3, V4. Voltage drop across R3 as well as R4. All are 40 voltage. Since the voltage is same across the parallel combination. Right? So now we calculated V1, V2 as well as V3, V4. Right? V1 is 60 voltage. V2, V3, V4 is 40 voltage. Then I2, I3, I4 that also equal. That is the total current. The total current is 40 divided by 2 is 2 ampere. Right? The 40 voltage is available across the V2 divided by the resistor is 2. I equal to V by R. V is 40 voltage, R is 2. So 20 ampere. The 20 ampere is flowing through the current, each and every resistor. I2, I3, I4. And also the total current is 60 amperes. So there are 3 resistors available. So equally divided 20, 20, 20. Right? Current across R2 is 20 ampere, R3 is 20 ampere and R4 is 20 ampere. The 60 ampere is 3 divided by 3. Equally divided by 3. So 20 ampere. That also another calculation. Otherwise I equal to V by R. V is V2. The I2 is V2 by R2. 40 by 2, 20 ampere. So now we can find the power delivered by the source. Vs, Is. Vs is 100 voltage. Is what we calculated 60 ampere. That 60 ampere only divided into 20 voltage in 3 resistors. So it is 6000 watts. Power delivered by the source is 6000 watts. Now we need to verify the voltage drop across each and every resistor. Power drop across each and every resistor should be 6000. That is the Tellegen's theorem. Power delivered equal to power absorbed. So that net power is 0 in any network. Sum of power in any network is 0. Now we calculated V1, V2, V3, V4, I1, I2, I3, I4. Then we calculated the power delivered by the source. Now we will see power absorbed by the resistors. So total power dissipated by the resistor equal to, there are 4 resistors available. So V1, I1, V2, I2, V3, I3, V4, I4. Right? This is the first resistor connected. Then these 3 resistors are connected in parallel. R2, R3, R4. So we know the value of V1, V2, V3, V4 as well as I1, I2, I3, I4. V1 is 60 voltage. I1 is 60 ampere. Right. V2 is 40 voltage. And V3, V4 also 40 voltage. Similarly, I2 is 20 ampere. I3, I4 also 20 ampere. Right. The voltage across R2, R3, R4. Similarly, current flowing through R2, R3, R4 also equal. 40 into 20. So 60 into 60, by simplifying all this, what we got? 6000 watts. Right. So this power dissipated also is 6000 watt. Earlier we calculated power delivered by the source also 6000 watts. So as power delivered is equal to power dissipated in the circuit, the Tellegen theorem is said to have been verified. Right. So power delivered as well as power absorbed is what we calculated are equal. So that the Tellegen's theorem is verified. So in this problem, we verify the Tellegen's theorem. First we calculated the voltage across each and every element, current through each and every element, then power delivered by the source, then power absorbed by the each and every element. If both are equal, we observe that both are equal. So the Tellegen theorem is verified. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.